Hello and welcome to Empowered Learning. This particular video will be about graphing techniques and in particular about graphing transformations. What we will be doing in this particular video is taking parent functions and from that looking at key points of that parent function and morph it into other functions in which we do such things as vertical shifts, vertical stretches, horizontal shifts, horizontal stretches, and reflections about the X and Y axis. So let's go ahead and get started. So first, what we want to do is talk about vertical and horizontal shifts. If we do a vertical shift upward, then what we're doing is taking the graph of our base function and adding 3, in this case, to all of the y values and virtually lift the graph up 3 units. Okay? So the difference in between x squared and x plus 3 would be just, we would add 3 to all of the y values of the original function x squared, which we see its key points that we've identified over here. And so if you notice, each of these values here, we're adding 3 to all the y values, but the x values stay the same. And so because of that, we see that we end up having just a vertical shift. So in general, if we had a function f of x, if we had f of x plus k, this would be the vertical shift upward by k units. So if we were to look at an example of a vertical shift up and a vertical shift down at the same time on our calculators, this is what it would look like. So of course the dark function that you see here is the basic x squared function, whereas the function below is x squared minus 2 and the function on top is x squared plus 2. All right, for a vertical shift down, of course, instead of moving the function upward, we're moving it downward, and how we accomplish that is by subtracting 4 from all of the y values. So here we would subtract from y values. So in that instance, you'll see that we still have the key points here, but now instead of adding 3 like how we did last time, now you see that we are subtracting 4, and all the y values follow suit. For a horizontal shift to the right, now instead of having the entire function being added or subtracted by a particular number, now we just have the part where it's just the x that is being, in this case, subtracted. So whenever we have x minus 2 quantity squared in comparison to x squared, well, you'll see that from these points here is that we are going to subtract 2 from all of the x values. And so because of that, you'll see that here the point 2, 0 right here is what happens after we add 2 to all of the x values. All right, so if we wanted to get a better idea of how the graphs, or in this case the points, actually come about, then what we could do is start off with a set of points and then from that see how these points are morphed into the points that we see here on the graph. Okay, so let's take a look at that. So here again, let's do our points here. Let's say we'll go with what we have: -2, 4, 0, 0, 2, 4, and 4, 16. Okay, and so this is for the graph of x squared. If we wanted x minus 2 quantity squared, then what we would do in this case is just take these particular x values and add 2 to all of them. So -2 plus 2 is 0, 0 plus 2 is 2, 2 plus 2 is 4, and 4 plus 2 is 6. All the y values, since this is a horizontal motion, would remain the same. And if you notice, we see that the point 0, 4 is on the graph. We see the point 2, 0 is on the graph. And we also see the point 4, 4 on the graph. And if we would keep on drawing up going this way, we would also see the point 6, 6 on the graph as well. So again, if we wanted to see horizontal shift in our calculator, we have base function x squared, and then we have x minus 3 quantity squared, which is shifting the x squared graph to the right 3 units. And then we would have x plus 2 quantity squared, which would mean we are shifting the graph to the left 2 units as well. So now for another example of horizontally shifting to the left, we see that we have the graph of the function x plus 4 quantity squared. So of course, in this case, we see that the graph is shifting to the left. Now, what this literally means is this. Okay? So we're basically saying, hey, take this point 0, 0 and shift it over to where now it would be -4, 0, and do all the other points similarly. So you can see why, even though this is plus, why we would actually be shifting over to the left. Okay, and so similar to how we did the last example, we know that for these points here, we got 0, I'll just make up 0, 1, 2. And so, of course, if we, for x squared here, that would just be 0, 1, and 4. Now for x plus 4 quantity squared, that would be a shift over to the left 4 units. So we would have to subtract 4 from all of the y values. And then from that, keep all of the x values the same. Sorry, the y values the same. Okay? And so you can see here on the blue graph, we have the point -2, 4 there. We have the point 4, 0. And of course, if we would have did, another point here, then we would have got this particular point as well. All right, so now we're going to combine vertical and horizontal shifts together. So here we see that we have a graph of f of x, which is x plus 3 quantity squared minus 5. And so if we start with our original function, then you see how we shift everything over to the left 3 units because we have the plus here. And then this minus 5 on the outside says that we shift everything down. So you see how we start off, we move this point over 1, 2, 3 units over to the left. And then from there, we shift it down 5 units. So it comes down here. And that is the graph that you see here. So next we're going to talk about compressions and stretches. So a vertical stretch is a case when we have some function f of x, and what we're trying to do is stretch it by a factor of a, but a is greater than 1. Okay? In this case, since we have 2 here, since 2 is greater than 1, then we are vertically stretching. What we end up doing here, since it changes y values because it is vertical, we're just multiplying each y value by 2. multiply by 2, multiply by 2. And so what that essentially does is makes the graph rise higher, faster. And so we see the black graph to begin with, that's just absolute value of x. And then of course you can see for all these points, all the y values have been increased by a factor of 2. A vertical compression is similar, but instead of stretching the graph, it is compressing it or shrinking it. And here the same thing. We're still taking these values of y here and multiplying them times whatever points we have. Let's see, if we multiply all the y values by 1/2, we get these corresponding y values here. And so in general, whenever we have a vertical stretch, we know that because the number that's being multiplied by the function is greater than 1. And if the number is in between 0 and 1, then we know it is a vertical compression. Okay? We do not deal with negative numbers because we have another set of transformations that deal with negatives on our x values as well as on our y values. And we'll get into that next. So now we want to look at the graphs of functions using reflections about the x-axis or the y-axis. So a reflection about the x-axis, if you note, is a motion coming from, in this case, up to down. So that would be a vertical motion. Since it is a vertical motion, then you know that this particular reflection is going to affect y values. And as you can see here, for each of our y values, the one thing that changed was now all our y values are the negative of what they were. So we essentially multiplied all of our y values by a -1. Okay. And so here, whenever the right side of a function f of x is multiplied by -1, graph of the new function is y equals -f of x. Okay. A reflection about the x-axis, a good example for this is the square root function. And in particular, if we put a negative on the x of the square root function. So in that case, we see that square root of -x can only have negative numbers and 0 plugged into it. So in order to make that work graph-wise, of course, it would have to reflect about the y-axis in order to make all the values of x reasonable for you to be able to put in, of course, if they're all negative. And so again, in this case, what we're doing is instead of multiplying all the y values by a -1, we're actually multiplying all the x values by a -1. So our original graph here would have been something like this. Where now, oops, come up here, do it like that. So where now we know that this is for square root of x here. But now if we wanted square root of -x, then that would be 0, -1, -4, and the y values would remain the same. And so in summary, we have vertical shifts, which we know is a function plus some value k. K has to be greater than 0. And of course, some function minus k, where k has to be greater than 0. Of course, the graph is raised or lowered by k units accordingly. Then, of course, change, we add k to the y values. And so I'm just going to cross this out and put y values. And Here for the vertical shift down, we are subtracting k from the y values. A horizontal shift, whenever you have a horizontal shift to the left, do you see how you have the plus? And whenever you have a horizontal shift to the right, you see how you have the minus. And so here what you're actually doing is in the case of going to the left, you are going to subtract all of your x values by h. And the reason being is because this x plus h is really written like that. And of course, for the horizontal shift to the right, we're going to be adding h to all of our x values. Okay, so for here, add to x values, and here is going to be subtract from x values. That doesn't look so hot. So we have subtract from x values. And so for the compressions again, of course, in both of these cases, we're only dealing with this one here. So if a is greater than 1, then we know that it is a stretch. And if a is in between 0 and 1, it is a compression. And of course, the last thing would be our reflections. If we have a reflection about the x-axis, then it means the whole entire function is multiplied by a -1. And if it's just the x that's being multiplied by -1, then that is a reflection about the y-axis. Okay. And so in that case, we replace everywhere where we see x with -x for a reflection about the y-axis, or multiply -1 times all the x values that you have, and then for reflection about the x-axis, multiply all of the y values by -1 that you have. And so now let's look at another example here where we want to find the function that is graphed after following the 3 transformations. So we have a base function of absolute value of x, and then from there we know that we have to shift left 2 units, shift up 3 units, and reflect about the y-axis. Okay, so here if we do that, then we see the following. All right, so our original function is in blue here, which is just absolute value of x. And then after that, we have shift left 2 units. So now that turns into the x plus 2 because it's shift to the left. Okay, so that goes from here to here. After we do that, then of course the next thing is we shift up to the right 3 units. And so by doing that, our graph that came from over here to over here now is going up here. Okay, and then we want to replace, do the reflection about the y-axis. Okay, and so here how that looks is, of course, you would reflect what you see over here in the green. That would be reflected over this way. Okay, and so in this case, if I were doing this, I would probably do the third one first, and then after that I would do the second, and then the shift up third, just so that I can follow it, follow the transformations in order of operation. Okay, so now let's move to the next example here. And so now you see that we have one where the base function is 1 over x, which is your reciprocal function, which looks like this: wax on, wax off. And so now we know that for the function 1 over x, we have just multiplied it by 3, which gives a vertical stretch. Okay, and then after that, it is added to 1 there. Oh, sorry, not added to 1. We have the x minus 2 here. And so what that is the horizontal shift to the right. So in this case, there is a vertical asymptote here. And so we'll take that and everything will shift over to the right. So that's why you see this imaginary dotted vertical line there. And then of course the +1 says everything has to be bumped up. So in that case, what we see is that there is also an understood horizontal asymptote that's being bumped up as well. Okay. And so this is just to give you some other examples of what these transformations look like. So one last one. So for this one, we see the first thing we do is we deal with the square root of x, and then we have the x squared plus 1, and then they do the minus to it, and then after that they do the plus 2. Alternatively, we could have wrote this way. And when we do that, we would actually do the reflection about the x-axis, step 1 here. Step 3, we'll do that as step 1. And then the next thing we would do is do a shift. That'll be to the left. And so this would still be step 2. And then after that, we would have step 3 of this process by doing the adding 2. So that would be this. And so that's assuming that step 1, we don't include step 1 here. Okay. So you can clearly see how this morphs from being the basic square root of x function to the x plus 1, which is shift to the left. And then after that, you take it and apply the reflection about the x-axis. So you'll see how this now, let's say the point -1, 0, how that comes and now shifts over to here at 1, 0, okay, and going the other way. So that's why we see this graph here. And then of course everything is bumped up by 2 units. So getting it from here to being able to add 2 to it. And, oh, sorry, not -1, that should be +1. Excuse me. Go ahead and get that fixed there. And so that's why you see this point right here. All right, so this concludes the first installment of the graphing transformation videos. The second one I'll do is an actual exercise where we'll take a function and take some key points and plot the points from beginning to end to see what the resulting function will look like.